Hello everyone and welcome back. In the previous video we learned how to set up the signaling system. Now it's time to implement the WebRTC to our package. So I'll simply just copy and paste and explain since I have done it thousands and thousands of times. Now let's see what we have here. WebRTC Factory is the most important class here. Let's go from top to bottom. The first function that we are calling is to initializing PeerConnectionFactory. If we take a look at our initializing PeerConnectionFactory, we are creating some options for our PeerConnectionFactory and then simply initializing the PeerConnectionFactory using this option. And right after it, we will have a function to create the peer connection itself. So using that initialized PeerConnectionFactory class, now it's time to add the video decoder and video encoder and of course some options to PeerConnectionFactory, and then we are able to create our PeerConnectionFactory. So using this variable by lazy initialization delegation, we will be able to create our PeerConnectionFactory. Then we will have a function to prepare local stream. This function will allow us to open our camera and microphone and make a stream ready to add to the peer connection. So first thing it does, it calls another function named init SurfaceView, which will prepare our SurfaceViewRenderer to show the stream. And then we will go inside this function, start local video. So what this function does is create a surface textual helper using EGL-based context. Then we will have a video capturer class, which is of type camera video capturer, and then it will use the get video capturer function to open camera to animator class, find the front camera or the back camera, whatever you want to use it here, and then we will initialize the video capturer using surface context, textual helper, and of course the local video source capture observer. As you can see up here, our local video source is being created by PeerConnectionFactory. Same goes for the audio source. So we have initialized our video capture. Now it's time to start capture. This function will start running your camera. And after initializing and started the camera, now it's time to create the video track and audio track. Simply use the PeerConnectionFactory to create a video track, and of course we want to preview this local video track to the local SurfaceViewRenderer, which shows the user feed. And of course we have to create the audio track to open the microphone using AudioSource and the stream ID tag, which is being generated up here using user ID and underline stream. And then we will initialize the local stream, which is of type MediaStream, and add both of audio and video tracks to it. So with this way, we will prepare our local stream and make it available to be added to the peer connection. And this helper function is for destroying video capture, audio track, and releasing that stuff that we don't need here. And it's called onDestroy. And the last thing on this class is a function that creates the RTC client itself, and it will return an RTC client. So first let's look at the interface and then go to the implementation class. It has like 6 functions. It should know how to destroy the peer connection or the RTC clients. It should know how to offer, how to answer, and then we should be able to manage remote session receiving and ice candidate receiving, and of course the local ice candidate generation. Let's go inside the RTC clients. As you can see, the RTC client implementation will receive the peer connection and a callback to manage the generated packets. If you take a look at this callback, you'll see that the ice generation, the offer, and the answer generating. So at the peer connection of this RTC client should be the one that is being received from the constructor, and for the offer it's just some simple offering from WebRTC library. All you need to do is to create an offer, set it as the local description, and transfer it to the target. You of course have to some media constraint what to use from WebRTC. For now we want to use video and audio here. So this is the way that you create an offer and transfer it using this callback. And same goes for the answer. We simply use the PeerConnection, create the answer, set it as the local description, and then transfer it to the other target, and use the media constraint of course. And for other two functions, remote session receive, we simply want to set up the remote description. And of course for receiving ICE candidate, we want to add it to our PeerConnection. And for the localized candidate generation, we want to first add it to our PeerConnection and then transfer it to the other target. So these clients knows how to handle creating offer and answer, and of course receiving the session descriptions and ICE candidates. Let's go back to our WebRTC factory and create this function. This function will receive, of course, an observer, a listener from transfer data. So all it does, it will use the PeerConnectionFactory and create a peer connection. So to create a peer connection, you need an PeerConnection observer. If I press Ctrl P here, and RTC config. For the RTC config, we simply wanna use the static one inside the PeerConnection class and pass our ICE servers to it. Let me write something here. You can add your turn server to have a video call out of your local network. You must have it. You must add. If you don't know how to create your own turn server, I have some videos about it. I'll add it inside the description of the video. You can check it later. So inside the RTC configuration down here, we will pass the ICE server to it. And then you have the connection successfully. Now it's time to add this local stream that is being prepared to our connection and then return the RTC client implementation as the RTC client. So this function knows how to create your RTC clients with having the local stream and knows how to create an offer and send an offer. Pretty much awesome. Now one more thing is left. We want to set up the playing of the audio of the call to the speaker mode. Inside the main view model, I'll create a private val RTC audio manager. I'll use by lazy initialization, use RTC audio manager and create and pass the application to it. So let's add the application, and using init block, you want to use RTC audio manager and set default audio device to RTC audio manager, audio devices, and pass speakerphone. Remember, if you don't grant the permission of the modify audio settings here, you won't be able to play audio using your speakerphone. Now we know how to start our local stream. It's time to use these functions and run our UI. So let's move to the next video and set up the UI and starting the call. Till the next video, see you everyone.